Ready to start? Start broadcast. We're about to start. We'll give a quick countdown. Oh, that was fast.
I pressed it as well, so maybe that was why.
And we are live. Hey there, everyone. Thanks so much for joining us here. This is the second talk today. I think, either right now is wrapping up the resilience of SQL from this morning. And now today we have Dylan Anderson over there in the beautiful UK. How's it going, Dylan?
Yeah, it's not too bad. How about yourself?
Good. Well, I'm excited to see what you have to talk. I'm just here to give you a quick intro, but feel free to give a little bit more background on yourself, and I'll jump off camera.
For sure. Just some so about me for those who don't know me. I'm sure some of you know me from LinkedIn, but I'm a head of data strategy at joining a new consultancy called Profusion. I've been in consulting for about 10 years now, and I joined the data space, and I've known and worked in the data space for full time the past 3 to 5, but I've coded in R for about 10 years as well. And where my focus is really about the data strategy and about really understanding how an organization needs to use data to achieve and work through their business goals. And part of that journey has led me to kind of the topic we're going to discuss and go through today, which is the data ecosystem. So I'll dive in. I just want to say, please feel free to ask questions, throw stuff up on the chat. Happy to answer. My material will probably go around half an hour, maybe 40 minutes, but I do want to answer questions at the end. So anything that comes to mind, either about data strategy, about how I see data engineering or machine learning within the data ecosystem and with big clients, feel free to let me know. And with that, let me know if you can't hear me or anything else happens. Great. So I want to start with the data ecosystem and talk about the data industry in general. So if you look at Data LinkedIn for about 10 minutes, you find a consistently growing list of problems in the data field. So poor data quality, lack of leadership support, unrealistic requests and timelines. And the thing with LinkedIn is these problems continue on and on and on, and they never really get solved, especially at large, big organizations that really don't understand data. But as we all know, data is still growing. It's still well and healthy in a lot of people's minds. And the growth of data is leading to a ton of outputs like dashboards, AI products, machine learning applications. And even despite these problems, there's more and more investment going into this type of stuff. And with more investment is more and more players. I mean, I think probably everybody has seen this, The Mad Data Landscape by Matt Turk, but it's just an enormous amount of companies are out there and they do an enormous amount of things. And no matter how much you zoom in, you can't really read what's out there. It's just brutal. And this makes it really hard to understand what people are doing and what companies actually stand for. What's their value proposition within data? So I love memes and I love data memes. So you'll see a few of these throughout the presentation. But is this a time for celebration within data? Even though there's all these still problems, we are still killing it. We're still growing. That's right. That's good, right? But then also, like, are we just super confused and just like carrying on doing things because it's delivering value and wondering and hoping it gets better? Grass is always greener. It's the question I've asked myself a lot. And I think the thing about these problems and what they entail from an overall kind of organizational perspective is these are symptoms. They're not root causes. And I think what's happening in the data world is we keep treating the symptoms. So let me expand on. So for example, poor data quality. This can link back to source data or no governance or a lack of data contracts or a lack of data literacy, inability to integrate data sources, poor engineering, or no data model, or a lack of enterprise architecture. Those are the root causes that underpin a lot of these problems. And we have them across the board. So what we see and what we talk about are often symptoms, and you can't really just solve poor data quality. You need to do a lot of different things to solve for that. And that's the big underlying problem I'm starting to see, and where kind of the idea of the data ecosystem came from. So what's the problem? as I mentioned, kind of we lack the overarching context. So this is a conference on two elements of the data ecosystem. So we have data engineering here, and we've got AI, ML over here, right? And so there's so much more to it. There's your data governance, there's your data quality, your data science, your analytics, the business strategy, the data strategy. And the problem that we have in today's world, in today's data world, is a lack of understanding of how all that fits together. What's the context that brings, for example, data strategy close to the AI and ML? And how do we think about those types of things in a more holistic way? And what we see today is everything is kind of separated and siloed. So how do we solve this stuff? For example, lack of data leadership support, let's say, that comes from three different angles. It comes from like the business strategy, it comes from the data foundations, or if we're talking about poor data quality, that could come from both the data platform or poor data management. A bunch of different root causes and different domains feed into these problems. And what we see is the nature of this silo nature of data and the data domains leads to these common symptoms because the root causes exist across the ecosystem. And teams aren't working across one another to solve those together. They're trying to solve them on their own. Poor data quality might get thrown to the data governance team on one hand, but also might get thrown to the data engineering team on the other hand. And they might not be working together to solve that in a consistent and holistic way, therefore leading to more problems along the way. So what do I keep talking about when I talk about an ecosystem? Brief science lesson. Ecosystem is a geographic area where plants, animals, and other organisms, along with weather and landscapes, interact to create a bubble of life. This is based on interactions with each other and their non-living surroundings, even if these are not direct relationships. And overall, it's a complex network of living organisms, the physical environment, and the interrelationships within that space. So why do I mention ecosystem and why am I? So it's also actually, before I jump into why, it's not a landscape. So a lot of organizations talk about a data landscape or a data ecosystem. An ecosystem I see as all-encompassing, relationship-driven, interactions across things. A data landscape is kind of usually the totality of an enterprise's physical data assets, tools, and technology. It's more kind of a snapshot and it's more technically focused. So that's the difference between the two and how I see it. Just give me a head to see what I had. And the reason I call this out is because a lot of people talk about a data ecosystem and what they're really talking about is the data landscape. They're talking about the tools and technologies that interact with each other and integrate with one another. When I'm talking about a data ecosystem and why I think it's so important is because we need to understand the holistic context within data. So what I see in the data ecosystem is 4 or 5 different parts. One, you have the kind of business influencers. Everyone always talks about, and they mention all the time, you need to think about what the business is doing. But no one really understands how to do that. This kind of entails, okay, how is the business set up with the org structure and operating model? What's the business model that you're trying to achieve? What's the business strategy and the needs of the business? And how does that fit within the data strategy and data investment? This helps flow into kind of both this the data lifecycle, which we all know so well. So through the data use cases and the approach, whether that be mesh, hybrid, whatever, and getting stakeholders on board during it, that flows into kind of the data lifecycle. And you can see from data sourcing, platform, integration considerations, data consumption. These are kind of the standard things that you see within the data world and you understand. But that needs to be informed and driven by the business at the beginning. And obviously, all of these things are underpinned by kind of governance, management, etc. This data lifecycle then flows into the business decisioning, which needs to also be considered. What's the data visualization, the dashboards, the literacy and culture within the organization to better understand data and use it to their advantage. You also have, and worth mentioning, just like an ecosystem, you've got weather, you've got other things like the sediment in the rock or the soil. things that influence the ecosystem but aren't really necessarily right there and you don't think of right away. So this could be surrounding influences like the growth of the data market, the build versus buy debate, data ethics, regulations, or it could be data detractors. So stuff like tech debt, investment costs, change management, and transformation that really prevent people from moving on with their data projects and moving on and understanding it better. So how this all nets out, and as I mentioned, it's not the same thing as how other companies talk about data ecosystem. They talk about technology ecosystem, and it misrepresents the complexity inherent in the data industry. And I will say that till the day I die. But as soon as like Gardner stops saying data ecosystem, I will be happy. So what? And you can say, I get it. You like ecosystems. What does this matter? So the impact of not thinking holistically and some realist quotes to support it. And again, actually, before I jump into those quotes, I work with usually billion-dollar organizations. And all these kind of organizations face similar problems and different problems. This is a consistent problem across them, is not having that perspective from the holistic level. And so a lot of these realist quotes are things and pain points I hear when I talk with organizations and when I help build a data strategy for them. So data is a black box. Don't understand what the data department does. Not helpful. Don't know how they got to those conclusions. Business stakeholders, without understanding and being involved in the data process, usually don't believe it and don't really get what's going on in there. And that makes them not trust what they do. And they go back to Excel and use the data they've done before. Symptoms have multiple sources. So I know we have quality issues, but I don't know where they start to fix them. Is it engineering? Is it governance? Is it tech integration? This goes back to the underlying knowledge that most data quality is just, it has multiple sources of root causes. So it could be that it's bad source data. It could be that the pipelines aren't built to scale that, or that there isn't a data model to help structure these things. But the problem is tech people who own the source systems aren't talking to the engineering team, who aren't talking to or don't have access to a data architect to design the system. And then there's the data governance, data quality team, who might not exist in a lot of organizations. So those symptoms with multiple sources, obviously kind of a big thing of not thinking holistically. Groupthink, we've always just done it this way in engineering. Why would we change that? That's kind of, again, it goes back to the change management element. How do you learn from others to do things better? And without talking to other different domains, and with data being so siloed within a lot of organizations, you get we've always done it this way within the data team and external to the data team. Siloed perspectives. Again, we can't seem to get the data platform integrated with the technology systems the way the business needs and actually use the data. And again, that kind of goes back to the being separated from the key business stakeholders, not understanding and talking to them on an ongoing basis. Too many cooks in the kitchen. I'm not sure who to go to. Teams all blend together, often do very similar tasks. This is the idea of shadow data teams. So shadow data teams exist in a lot of organizations because business domains like marketing or finance are just tired of waiting for stuff to happen in the data team. So they hire a business analyst or a data scientist or a data engineer and set up their own stuff. And I guess the idea of data mesh was to help deal with this. But let me tell you, data mesh does not work like that in a lot of cases. But in general, you get too many people trying to drive a certain thing a certain way, and it becomes very, very confusing to follow. And then overall, not thinking holistically inhibits the direction of data. So there's so many things impeding our progress and don't know where to start, and they lose the funding battle and not driving value. And this is, I think, the biggest thing, because every organization and every person hears about and talks about trying to create business value. But what does that actually mean? And I think without thinking holistically, and holistically means outside of the data realm, where the business is doing certain things, whether that's selling products online or at a retail store, or even moving logistics from one place to the other. That needs to be considered in the everyday work that you do from a data perspective. And then you can try to assess and understand the value. So this is a data engineering conference. So I did want to kind of talk about data engineering in the data ecosystem. And over the past little while, I've done a lot more research on data engineering, done a lot of work within data engineering. I also do want to say that I have managed data engineering teams from a data strategy perspective. A lot of my clients need data engineers from a consulting perspective, and I kind of oversee how the data engineer best slots in and what they need to think about from a high strategic level. So the problem with data engineering today, though, is that they're hopelessly across the ecosystem. I think the word engineer means that everyone thinks that they could do anything. They're an engineer, they can do whatever, right? And I think data engineering has been placed in that way. So what we see is, well, we see them across the data lifecycle, from figuring out the data sources, the APIs, to of course, the data platform, from building the architecture to doing the engineering. Also integration, data privacy, security, testing, and even in data consumption, products, however you define them, or setting up the data science elements. So that stuff makes sense of what they're doing, but they're also dealing with the surrounding influences. So how do we scale? Should we build versus buy for that technology? What are the data regulations, and how do we kind of feed that into the pipeline discussion? Or in business decisioning, we need to create data literacy, and sometimes teams rely on data engineers to create the documentation that should go to business stakeholders and create the data culture, which is a bit kind of outside the domain of data engineering. And then finally, of course, all the data detractors deal with data engineering, from the tech debt to investment costs, they're expensive, as well as the change management and transformation. So this widening dependence is just reflected in everything I think the domain does. And I see this honestly as a breaking point. I was just actually chatting with a head of data engineering not an hour ago about potentially co-authoring an article in my newsletter, The Data Ecosystem. And we talked about how what we both see in data engineering right now is kind of what data science was like about 10 years ago, when data scientists were like, okay, you know what? I've had enough of this. People are asking me to do things and it's getting impossible, and I'm at burnout and I'm at a breaking point. And I think a lot of what's happening within data engineering is similar. So first, business people think that a technology problem is always a data engineer. So, if there's any problem with tech stack, just throw an engineer at it, even though that's probably not always the right case. And then this translates to ownership about what should not sit solely within the data engineering function. So this is based on an article I wrote a couple weeks ago. But for example, data engineers should do all these processes. They should own them, be responsible for them. Gray area around these ones. So they shouldn't potentially own data architecture design. There should be a data architect there, but they would be helpful in doing that. Same with kind of the data catalog integration, helping with that, but they shouldn't own the data catalog. That should be owned by governance in a way. Yet we see a lot of these things owned by data engineering, and while they should be involved, and maybe it should be owned by them depending on the size of the organization, they shouldn't necessarily have full ownership of them if there is someone else that can help provide that responsibility. Then these kind of areas are things that data engineering should not own. And you look at them and you're like, well, they should be involved, and they should be involved, but they shouldn't be the only ones doing it. And that kind of goes from requirements gathering, that should be a part an analyst job as well, to kind of data democratization, which should be more of a leadership role or a governance role. All these kinds of things are now thrown on the plate of data engineers, and it makes it a lot tougher to do your day job, especially when you're full on building pipelines and such. So, and I would even compare it to the famous chart here. So everyone knows this data engineering lifecycle. Here we've got So actually in the middle, we've got kind of the roles of the data engineer. So, your ingestion, transformation, serving with storage. And when Joe and Matt talked about it in their book, in Fundamentals of Data Engineering, they talked about you have to pay attention to all these things, but you might not be responsible to pay attention to them. Yet what we're getting is being responsible for it. So from a generation perspective, people don't understand how data is generated and where it's generated. And the technology owners who do understand that are not plugged into the data teams to help facilitate that knowledge. So this often falls on the engineers to figure out what are the sources providing? How do we actually connect and integrate those sources? And that type of thing really doesn't bode well for scalability. Second thing is on the front end. So analytics, ML, reverse ETL. The first generation of data engineers had a lot of that analytics and data science experience. All those data scientists, the move to data engineering, and they could reference that experience in their work. And so organizations have come to expect that background and that domain knowledge. So, for example, I'm working with an organization right now that is trying to build data products, and they're in a mesh architecture, or organizational structure. So a data product for them means how the data product will then feed into the analytical solution. And they expect the engineers to build those things. But the engineers don't know how the business works. They don't know what kind of solutions are being built on the front end. And that creates a lot of problems. But they're expected to do that. And therefore, a lot of the data products and the builds have failed. And I think that's one thing that organizations are starting to realize, but not fast enough. And I mean, that's why you do see some analytical engineers coming to bear. And then finally, the undercurrents. And obviously, data engineering ears should be understand these different undercurrents, but these functions and domains are often super underinvested in. I know a lot of companies, large organizations, who have like one or two people on security, one or two people on management, and maybe no software engineers. And while data engineers should be involved, they shouldn't be responsible for all these things. And there's some things that maybe they'll take responsibility for. So, for example, orchestration or software engineering, depending on what you're producing. But from a large part, these undercurrents, because they're necessary to think about when doing the work, it falls on the data engineer to better understand them and deliver against them. So within the article I wrote a few weeks ago, I identified kind of 4 strategic issues and categories of why I believe data engineering is at an inflection point. And overall, I see it's been so essential to success, but broken in how it's operationalized. These 4 areas are strategy and leadership, or lack thereof, a technical focus of the domain, the isolated role of data engineers within the organization, and leadership's perception versus the actual reality of delivery. What I'd say to this, and I'm going to jump into each of these in a bit more detail, is this kind of culminates from what I've seen as a kind of head of consultant working with across multiple organizations. A lot of I'm not in it on a day-to-day basis from engineers, but I am talking to engineers on a day-to-day basis. I understand what they're doing. I understand what they're feeling. I also know that a lot of individuals who are plugged into the domain, like Ben or others, have written about these things as well. And so that's kind of where these are coming from. And what I'm going to try to do is identify the strategic issues that we see and potential solutions about how to start thinking about them moving forward. So the first one, strategy and leadership. So leadership often views engineering as a supporting technical foundation, limiting the direction and clarity the domain often needs. So the challenge is kind of developing engineering leaders. So there is a clear lack of career progression and skill development because most engineers are trained on very technical skills. And it's hard to learn core leadership skills within organizations, especially with what you have in front of you. There's often no engineering strategy. I mean, I'm a data strategist. I love strategies. But without a strategy, businesses operate reactively without considering long-term scalability or business alignment, and it leads to technical debt and burnout, or it leads to them hiring junior data engineers without actually thinking about why they're hiring them. They just need to fill more tickets. The third one is business leaders don't understand the domain. As I mentioned before, people think data engineers can do every backend data activity, and they treat data engineering as a cost center rather than a value driver, leading to unrealistic expectations. And this is huge because if you don't understand what it's going to do and how it's going to drive value, you're never going to realize the expectations that have been set out. So some potential solutions, and again, take these with a grain of salt. They're high level, but I do plan to do more work on this actually and write an article about it as well. So from a developing engineering leaders, proactive learning by data engineering, interact more with other data leaders. So learn from people who are doing other things within data, because you will get a lot more soft skills and learn a lot more about how to think about the business in different ways. And in addition to training for those soft skills. So whether that's communication or business problem solving, what does that mean? Second one, strategy. Actually developing a data or an engineering strategy be helpful. A lot of you don't necessarily have the power to instigate that. Another thing that was evaluating long-term work against short-term work. What is it that we need to do in the long term to help us in the short term, and stop thinking about ticket. Also integrate with other data team strategies. There's often a data governance strategy or an overall data strategy in general. And so how do you integrate those things together, and how does that inform the data engineering strategy? And then business leaders don't understand the domain. Show the work and try to demonstrate the value. I think that's the biggest thing. What is the technical architecture? How does the data flow? What are the usage reports in there that you can then point to and be like, look, the work we're doing is facilitating all this data to create this really cool thing, and that needs to be done. And if there is that alignment with what value is being delivered from a solution perspective, and all the pipeline maintenance has to be included in that calculation. And I think data engineers need to put their foot forward a bit more to be like, I made that happen, or we as a team made that happen, and take some credit for what they've done. So the second big category is the technical focus. So what I would say, and I've worked with a lot of data engineers, and I've seen good and bad, but only the best engineers think holistically beyond the technical details, an art that's being lost with junior engineers and the advent of AI supporting tooling. So the current challenges are priorities of junior engineers. They're really fixated on the latest tools and technologies without grasping the fundamental data principles. So these pipelines that are built aren't necessarily robust, scalable, or fit for purpose. Think about how the data model, think about the business processes, think about what you're trying to, the questions you're trying to answer with your things. That is not being thought about because they're thrown into and just doing ticketing stuff. The second one is lack of holistic thinking. So data engineers aren't exposed to other domains, and it results in siloed workings and a lack of exposure to the bigger picture. Third one is AI. There's a growing reliance on AI to help code and do things, and a lot of copy and paste code doesn't really help with scalability. And this is worse for new engineers, obviously, who don't have that data science or software engineering background, because they don't understand the logic of how to code. When I learned how to code 10 years ago, I learned the logic of how things are structured and why they're structured in that way. And that helps me think about data a lot better, rather than copy and pasting and using code as a quick and simple fix. So potential solutions, again, for priority of junior engineers, learn other soft skills and try to present and draw implications to your work. Really thinking about the so what. So what does that matter? Why am I doing this? And what is it that we're trying to achieve? Talking to others about that will help you kind of get beyond just focusing on whether the code's right or the tools and technologies to do things. The lack of holistic thinking, again, learn about other related domains. So I just wrote about architecture this past week because I think that's something that every engineer should learn about, because that data modeling, even the conceptual data model, will help you better visualize how to build in a more sustainable and scalable manner. Also working with other data professionals and interviewing business stakeholders where possible. Obviously, you have time limits on how you do things, but understanding how the business is thinking about data, what they need, and what they'll help deliver, that you can help deliver, is really crucial in getting your logic and your foundations in the right way. Finally, with the AI bit, ensure you're building with coding and schema logic, and work closely with analytical and data science stakeholders. I would also add to this, model and emulate more senior engineers who really have built without AI, because how they build and how they think about things and do things is often really, really helpful for you to learn from. All right, the third category is isolated role. The things I've seen here is there's no exposure to the business. So often you get requirements through ticketing systems or project managers who don't really understand data engineering. And it really results in solutions that fail to understand the overall company's business model. The second one is not encourage to network. Businesses love people who network within the business, but data engineers and data people aren't necessarily told to go talk to other people unless it's planned. And that kind of not encouragement to network also happens within other data domains like governance, security, or management, unless they're at more of a senior manager role, which creates problems for some of the earlier challenges I mentioned of understanding the holistic picture within the data ecosystem. Third one is don't have supporting roles. I mean, I think I mentioned this before as well, but like data engineers handle a lot of aspects of the life cycle because they don't have data governance people or data quality people to help create those standards about what the data quality needs to be. And data engineers can't lead on these areas if they want to deliver high quality products because it's just too much for them to do. So potential solutions, I mentioned interview business stakeholders where possible, again, for the exposure to business. I reiterate that, but also add on, learn about the business fundamentals and models, especially if you work at an industry company and you're working in one industry for one company. You should know what that company does from start to finish. What's their business model? What's the processes that you're trying to build into for the pipelines and for the platform? Understand what that is, and that will help you so much in the work you do. Also, set parameters for what you do and don't do. This is huge. Sometimes people like to have a yes, we can do that mentality, but be like, okay, no, this is what we are doing. If you want something else, you need to go to another team or ask something about that. And that's a lot of that falls on leadership to do. The last one there is an optimal org structure and operating model. And I've talked about this in my newsletter multiple times, but the org structure and operating model is the skeleton and foundation for how a data team is successful. And within data engineering, often they're kind of put a bit siloed and isolated, and they don't feed into the right roles within how they do things. The second challenge, again, I'd say the exact same thing. Talk to business stakeholders, have a better org structure and operating model, and learn about other related domains, especially architecture. And then the supporting roles, again, learn about other related domains, set parameters, and also push back on expectations. I think I love to see people push back on expectations if it's warranted and if it's justified. And I think, I mean, that depends on where you are in the organization, also where you live too. The US has a lot higher demands than Europe in some case. But understanding what you should be doing and what you shouldn't be doing is crucial. And it's important for leadership to know that too, because often as a data leader, your juniors say, oh yeah, I can do that. And then they don't do it. And you're like, why couldn't they do that? And they're not truthful and upfront of like, look, that is something I don't really know and really understand. You can help me get there. But I think as a team, we're not going to get there unless you hire someone to do that or bring someone in to help with that. So pushing back on expectations is actually helpful for leadership as well. It's not just, it's not a reflection of your poor quality or your inability. We need a support to do that in a better way. All right, the last one, perception versus reality. I'm sure all of you have faced this before. The current so without clarity on what they should be working on, or the data will support them, engineers are held to impossible expectations. And the first one of that is designing optimal systems. I think leaders think that optimal systems can just be built and then they exist for like 10 years. But realistically, they need iterative thinking and rework. And that's kind of why I pushed an engineering strategy on a lot of these things, or technology strategy for organizations. And what I see mostly is necessary resources aren't invested to better understand how to build and address and design these optimal systems. And that's across companies. Constant ad hoc requests. So I've mentioned this a lot, but companies treat data engineers as on-call support for any data-related issue, and it's just urgent ad hoc tickets, and that really disrupt planned work or project timelines. And it goes back to that long-term versus short-term thinking. Data is such a firefighting industry that they are constantly fighting fires and doing short-term things that nobody cares to think about the long-term activities. And once you think about the long-term activities, it doesn't last for very long. And honestly, that's why I have a job, because sometimes companies have to hire out consultants to do those long-term activities because internal people don't have enough time. The third challenge here is high cost, high expectations. So everything about data engineering is expensive. And so there's pressure to deliver immediate ROI, leading to rushed implementations or focusing on short-term gains. And I think this goes back to the lack of leadership's understanding of data engineering as well. If they just see a dollar figure on that and are blown away, both from the technology perspective as well as the people perspective. And this makes people ask more of them. And that creates a lot of issues within the data engineering teams and within a data team in general. So solutions, optimal systems, data architecture, data architecture, data architecture. Please design data models. Make them work for the business. Make them flow from the business processes to the logical and physical data models. Don't start at the physical data model because it is not the right way to do it. And do that through sprints. Have check-ins every 6 months or something like that. And that could be the data architect. It can be a short thing, but make sure, is this still working? Is this still the same? Should we change it? And communicate the dependencies between them. And so that having a tech architecture diagram, honestly, can be the most effective thing in the world. But a lot of companies don't do it, or if they do have it, it just looks like spaghetti because of all the connections. The ad hoc requests, again, set parameters, what you do, what you don't do, and set a priority queue as well for systems for requests. The other one in there is invest in data literacy. And that's more of an organizational thing. So people know when to go to data engineers and when to talk to them and ask them to do things. Finally, high cost, high expectations. Try to demonstrate value. I think the best thing, and I think I mentioned this in my article this past Sunday, but data architecture can really help with demonstrating the value of data engineering because it can show how things flow together, how data gets from one thing to another, and then how data feeds into business problems that the organization and company is trying to deliver on. Without creating that visual, that view, people don't understand how the pipelines are actually providing value for business stakeholders who are selling more gadgets or doing whatever they do. And then the other two I've mentioned before, but setting parameters and pushing back on expectations is just crucial. You can't burn out, and I don't want to see a bunch of data engineers burn out. So I will keep on saying that. Make sure that people understand what you're doing and what you shouldn't be doing, because if you don't, you only have yourself to blame. So I think that's everything, honestly. So it was a whirlwind of stuff about the data ecosystem and about my view of data engineering right now. Again, I'm not a data engineer, I'm a data strategist, but what I see in the data ecosystem and within the world of data right now is a lot of focus on data engineering, and it's important to sustaining the data ecosystem. We can call right now, if you want to look at an ecosystem view, it's like the pond or something. So yeah, I would say follow me on LinkedIn if you haven't. Also subscribe to my Substack. So a lot of this content, a lot of this thinking is coming through my Substack because I think short-term content or short content on LinkedIn doesn't quite do it justice. So, I mean, what I try to do is create a 5 to 7 minute read every Sunday morning on new products. I've got 3 articles lined up for the next 3 weeks on data products, everything from what a data product is, the data product supply chain, which includes how data engineering is done, as well as how to operationalize it and how to actually deliver a data product. And in this case, by the way, data product I define as an analytical solution. So yeah, and I've got a Medium too, which I don't use that much, but it's there. Now, okay, so my presentation went 40 minutes. I want to open up to any and all questions. So if there's anything anyone has, feel free to put it in the chat, in the session chat, and happy to answer it. Data engineering, consulting, strategy, all of it is within my remit. And if I don't know it, I will be honest.
In the Q&A actually. So let's see.
Oh, there's a Q&A. Nice.
Yeah. But sometimes it's easy to miss for both people who are speaking and in the chat, because it's just easier in the chat.
Yeah.
So go ahead.
Oh, you can. I can read it. If a company doesn't have a good data strategy and a lot of data products are in flux, what are your recommendations to getting better organized? So it's a great question. I think a lot of companies don't have good data strategies, and a lot of data products are in flux in a lot of organizations as well. I think the first thing is to talk to the main business stakeholders. So I'm thinking managers, directors, of what are your priorities? What are your priorities from a business perspective? And for example, it might be, oh, we need more. I work a lot with media organizations, and their biggest priority is, oh, we need to grow our audience. We need to get more people watching TV. And you're like, okay. And then you figure out how data kind of can help with that. You're like, okay, well, we can build something that helps you identify what shows and what aspects of your show people like the most, because we can look at when they're watching and when they're not watching those shows, or when they cut off and there's churn, for example. And so by understanding those types of business questions and business problems that are top of mind for business stakeholders, that helps you then prioritize. And I think prioritization is something that companies don't do enough of. They tend to just do first in, first out. So whatever is top of the list, and then the next thing goes to the top of the list. And then nothing that gets solved is actually super prioritized for the organization. And the other way companies do it is the data team will just build something or do something, and the business stakeholders won't necessarily be involved. So the key thing is to kind of have that coordination, that collaboration of what are you trying to achieve? How do we build something in the data realm that will help you solve for that type of thing? And then go out and build it, but build it in a collaborative, iterative way where you're constantly checking in with the business and like, hey, is this what you want? Is this what you need? But while you're kind of pushing the agenda of like, this is how it should be represented if this is what you need. I hope that makes sense. But yeah, it really is about kind of having someone own that process as well. It could be a project manager as well, or a product owner, or a data strategist if one exists in the organization. If I didn't answer your question, let me know. The second question I see in the Q&A is, what role do you see data observability playing now and in the future? So I really like data observability. There's a lot out there, but I think there's too much reliance on it being a sole option for fixing things. Data observability is like an alerting system, which is great when you don't have alerts, but it still creates a lot of work, especially for organizations that just use observability willy-nilly and don't think about like, oh, this will take a lot more work than it needs to be. So I'm bullish on the realm of data quality, and I'm going to extend it from observability to data quality, because I think it actually needs to be more of a platform approach. I'm actually working with an organization now who's kind of tackling it more from a upstream version. So attacking data quality before it actually goes into source systems, before it goes into engineering, so that you know what you're doing, instead of just alerting something and being like, okay, I need to fix that, but I don't know why I'm fixing it. So that's kind of the dichotomy I see, but I see it getting better because data observability is super hot right now, and I could just see it continuing to get more popular and more important. Okay, we got a lot of questions in the Q&A. This is great. All right, if a company, oh yeah, nope, I already answered the first two. What's your first steps as a data strategist in helping a new company with no data infrastructure and looking to start using data? Great question. So again, I think it ties back to my first one, but it's understanding what to use data for. You don't need a huge new, you don't need like Databricks or Snowflake or something to get started. You just need to really understand why you need data. And I would say is understanding kind of what that data vision is. What do we want to do with data? What are some use cases to help drive that data vision? And then what do we need under those use cases to actually action those types of things? And what's the action plan to deliver it? I would say if they're completely greenfield, think the other thing to think about is what you want to do today, but also what you want to do tomorrow and what you want to build into and what's realistic. And that will help you kind of structure it from a long-term perspective. That being said, if you don't have that many resources, don't do a ton of work. Don't do a full data strategy. Focus on like a proof of concept and really start to build that type of stuff in a way that shows value immediately. So this might be a quick dashboard for executives to look at the key KPI, the KPIs of the company and the organization, or it could be like a small tool for sales teams to better understand whether their sales pitches are effective or not. I don't know. But keep it simple, keep it straightforward, produce the value, and then you can start to think about the infrastructure, what the long-term ramifications in the modeling needs to be, and how to build that on top of it. As a junior self-taught data engineer, how should I learn or improve scalable design or underlying schema logic for coding? I would say the biggest thing, again, I am not a data engineer, so I'm not going to say learn Spark, Hadoop, or whatever. I don't know any of those things. I'm going to be completely honest. I would go read Ben's stuff. Ben's stuff is really good for junior data engineers. That's one suggestion. The other suggestion I'd say is learn about the business. Learn about data modeling and data architecture and what that means to help kind of map systems out. I don't have, wish I had for example, like a conceptual data model just basically maps out what the business does on a day-to-day basis. It maps out the business processes, and then that layers down to a logical data model and a physical data model that can help you then feel like, okay, this is how I should design my schemas. This is how I should design my code to make sure we can get X to Z, right? And make sure to build it in that way. And I think it's just building in a way that makes sense and is logical and taking a step back. Because I think we're focused it's hard to do scalable design unless you take a step back and look at it from a holistic perspective. And I think doing that more often will help you become better at that. And also the other thing is just pay attention and learn from your senior engineers and heads of data engineering. They know how to do this, and getting their feedback and perspectives on it is really important. Don't be afraid of feedback. I love feedback. I get it all the time. I always ask for it. And that's made me a better consultant, a better data person. Pros and cons of data engineering consulting. I'd love to start consulting. Where do I start? So if you're in consulting, so if you're doing your own freelance stuff, I can't really recommend it, or I can't comment on it because I've never done it. But to get into data, so I would highly recommend doing data engineering consulting rather than working at a corporate or an industry company, because it exposes you to kind of the learnings you wouldn't get at an industry. Within an industry company, you are contained to the engineers they have there, the head of data that they have there, those types of things. And sometimes they're great, sometimes they're not so great. Whereas if you start your career and learn at a data consultancy, you have access to resources that you wouldn't have anywhere else. You can get and paid for training courses, Databricks certifications, for example, and other people who've done this stuff on a day-to-day basis. And you're constantly building, you're constantly doing new things. Either you're being outsourced on a day-to-day basis, or you're doing a migration or some sort of other data engineering work. And that kind of keeps your skills up, and it helps you advance a lot faster from a knowledge perspective. Then I would say once you get to a senior level, it's probably good to go and back into industry where you're more client, when you have a bit more experience in that realm. The other element that I'd add about consulting is it helps you develop your soft skills. As a consultant, you should be interacting with the client, communicating a lot of things, building those relationships. And that's something that you don't necessarily get internally at an organization. So I would say it is really beneficial if you're able to do it. But if you're also in an industry company, you can still learn a lot. You just kind of sometimes have to go above and beyond. You have to think beyond what everybody else is doing and make sure that you understand why you're learning and be into it and be passionate about it. One more question in the Q&A. So I'll read it out. I'm working in a manufacturing company that wants to keep track of their products via IoT data collection and do something useful with that IoT data. The thing is that products are pretty complex and the data team is 2 FTEs and 1 intern. We don't understand well how the products work together, neither the business. I kind of feel lost, honestly. What would you do? By the way, products are pretty big and complex HVAC machines or systems. Yeah, that's tough. I would say one is push back into what is realistic. I think that's the biggest thing is like you can't, for example, you can't create a digital twin with a 2-person data team. And I'm sure that's kind of what they want is a digital twin. So be realistic, set out different options. It's something I always say in consulting is don't come with problems, come with solutions. So what is it that you can do that would make a dent in what the company is asking for? And think about that. And you might not be hitting 125% of what they're asking for, but you might hit 70%, and that's good enough for now. And actually map that out. How long will it take to build that? How long will it take to do other things? And look at other use cases within the industry. Often a lot of other companies have done these things. That's one reason why I love going to meetups and networking sessions. You got to hear what other people are doing and what other companies are doing. And people are pretty open with what they do at work. It's not really that confidential because it's just more conceptual in nature. So learning from others in the industry and the area is really helpful. Also, I mean, you can press your leadership to send you to a conference or two, and that might help. So that's my best advice, but good luck. I think that's all the questions there right now. So any others out there, or otherwise we can end 8 minutes early?
Yeah, no, I think that's good. That was awesome. Thank you so much, Dylan.
Oh, thanks, Ben. Thanks for organizing and thanks for getting us going.
Yeah. No, thank you everyone who was in this chat. Do check out some of the other things going on. We have a pretty stacked panel coming up with several like VPs of data, one from like CNN and a couple other large organizations. So if you want to learn more about that, you should check it out. Awesome. Well, thanks y'all. Thanks again, Dylan.
Sure. Thanks everybody. Have a great rest of your afternoon or morning, wherever you are.
And I'm stopping.